Welcome to this course where you will be learning everything there is to know about single and double underscores in Python names. If you have been exploring libraries or you have been reading someone else's code, you might have come across variables or other objects that start with an underscore and some that don't, and some start with two underscores or even end with an underscore or start with two and end with two. There's even the use of the underscore on its own. What's all that about? Well, that's what this course will explain in quite a bit of detail. In this course, you will learn how to follow naming conventions in Python for better readability, because you will find that these underscores and the way they are being used is all linked with naming conventions. You will learn how to differentiate between public and non-public Python attributes. You will learn how to signal the use of non-public attributes explicitly, for example, with underscore validate, so you start with an underscore. You will learn how to enable name mangling in multiple inheritance scenarios, for example, with double underscore, so underscore underscore attribute. You will learn how to define special methods, also known as Dunder methods or magic methods, for example, the len Dunder method. And you will learn how to avoid a clash with Python's reserved keywords and built-ins, for example, list. So the contents of this course is as follows. We'll start with naming conventions, talking about PEP 8 and PEP 20, public and non-public interfaces, about leading underscores for non-public objects, name mangling in multiple inheritance. We'll talk about Python's special methods, Dunder methods or magic methods. You'll learn about conflicts with Python keywords and built-in names. And finally, you'll learn about additional uses of the underscore in Python. This course touches on a few topics that ideally you will have some level of familiarity with. You'll be studying examples that involve constants and functions, and variables and classes and methods and attributes. And if these topics are completely new to you, that's no problem. There are a number of excellent tutorials to get you up to speed, and I'll include links to these tutorials in the course. I am really looking forward to going on this journey with you, so let's get started. When talking about naming conventions in Python, there are really two PEPs we need to talk about, PEP 8 and PEP 20. A PEP stands for Python Enhancement Proposal. So a PEP is a design document that provides all sorts of information to the Python community. Let me guide you through the relevant section of PEP 20 first. PEP 20 is the Zen of Python. These are the guiding principles for Python's design. And to find out more, you can enter PEP 20 in your favorite search engine. But the Zen of Python actually has a cool little Easter egg that I would like to show you. And for that, we will need the REPL. So please go to your terminal. And in your terminal, type Python to start the REPL if you are in Windows. Type Python 3 if you're on Mac. And for Linux, it is either Python or Python 3, depending on your distro. So for me, it's Python. You then see the three arrows there in front of your cursor. That means you're in the REPL. And all you have to do to find out about the Zen of Python is type import this. What you will then get is 19 aphorisms about Python. The one I wanted to show you is the 7th one down that says readability counts. So readability is very important, and we will come back to that in a minute. For reference, I've included this screenshot in your slide deck, so you can come back to that later so you don't forget about the import this Easter egg. And the one that was important for us at the moment is readability counts. You should, however, also consider PEP 8, which is the style guide for Python code, and it describes Python coding conventions. So in this guide, you will find the following section. It reads, one of Guido's key insights is that code is read much more often than it is written. The guidelines provided here are intended to improve the readability of code and make it consistent across the wide spectrum of Python code. Now, Guido here is Guido van Rossum. He's the founder of Python, so he created the Python programming language. But the key points here are readability and consistency. And if you keep reading PEP 8, you'll also find a section called Descriptive Naming Styles. And on the following slide, you'll find a summary of the naming conventions that are relevant for this course. So this is a summary, and these are the naming conventions we'll be talking about. The first one, single leading underscore, for example, underscore validate, indicates that the name is meant for internal use. And we'll come back to what that means in the next lesson. There's a double leading underscore, like underscore attribute. That triggers name mangling in Python classes. And again, we'll come back to what that means. There's the double leading and trailing underscore. So len underscore, as an example. That indicates a special magic attribute or a magic method that Python provides. Then there's a single trailing underscore, list underscore, for example, and that is used to avoid naming conflicts with Python keywords and built-in names. And finally, we'll look at the single underscore used as an underscore, and that indicates a temporary or a throwaway variable. Later on in the course, you'll see two more uses of the single underscore. Firstly, in a REPL session, an underscore holds the value of the last evaluated expression. And secondly, since Python 3.10, the underscore is used as a wildcard in structural pattern matching. What that means, you'll cover that in more detail later in the course. Conventions are optional. They are not rules, they are guidelines. But as you saw when you were exploring PEP 20, Zen of Python, and PEP 8, the Python style guide, conventions are created to improve readability and consistency. Therefore, they are considered best practice. Sometimes, however, they are more than just best practice. Your code might actually crash if you don't stick to conventions. If you move to the REPL, we can work on a little example that shows you what I mean. In your terminal, you will find the REPL still open from the previous session. If not, again, type Python or Python 3 to open the REPL. And a little tip here, if you want to clean your screen, which I tend to do, I press Ctrl+L, and that cleans your screen. So in our example, you will be creating a little class called person, where the class only has one property or one attribute, which is name. So type class person with a capital, that is a naming convention, and then colon. We then see the 3 dots. In the REPL, we need 4 spaces for indentation, so 1, 2, 3, 4. Quick note here, if you are using Python 3.13, you won't have to bother with calculating indentations. The REPL in Python 3.13 has been upgraded with a number of cool features. Now, I haven't upgraded yet, so I am still counting. Type def __ init, INIT, __, open brackets self, comma name, colon, enter. Now we need 8 indentations, 1, 2, 3, 4 to be at the def level, and then 1, 2, 3, 4 to indent from def. And here you type self.name equals name. The __ init __ method is called a dunder method, and we will talk about those methods in a bit more detail later on in the course. But for now, please know that the init method is needed to make your class actually work. If you don't know about classes and how they work exactly, I'll include a link to a real Python course that explains classes in a lot of detail. But for now, let's just leave it at that and go, okay, we have our little class. Press enter. You see the 3 dots. Press enter again, so you see the 3 arrows. And now let's try to instantiate this class. So type me equals person with a capital. This is where you call the class, and you have to give the person a name. So in my name, or in my case, that is Stephen. I'll press enter, and nothing happens. But importantly, as we will see later, there is also no error message here. So this means this class works properly. What I could do, for example, is ask what the name of this person is. So I could do me.name, and you can see that the name of this person is Stephen. So far, so good. So we have a working class. What I would like to show you now is that if you deviate from the init function, where you have __ init __, that the code will actually crash. So we're going to create the same class again, but instead of using __ init __, you will be leaving off the 2 trailing underscores. So let's start again. Class person, press enter, 4 spaces, 1, 2, 3, 4, def underscore underscore init. And now let's leave off the trailing underscores and let's type self and name. Now we need, again, 8 indentations, 1, 2, 3, 4, 1, 2, 3, 4. And the same thing, self name equals name. We have now created a class. Press enter twice so that you get back to the 3 arrows. And now let's try to instantiate the class again. So me equals person. And then as a name, I'm going to use Stephen again. And hit enter, and you will get an error message saying person takes no arguments. The actual detail behind the error message is not important at the moment, but what I wanted to show you is that if you don't stick to the convention of having 2 trailing underscores after init, that your class won't work. For reference, I include this example here in this slide deck. And so now that you know how important naming conventions are and when you should use them, you learn about public interfaces and internal use in the next lesson. I'll see you there. Public and non-public interfaces in Python. What is an interface? Well, when you are writing your code and you are using a Python package or a built-in function, you are in fact accessing that package's functionality via its interface. The interface is the way you interact with a package or a built-in function. That still sounds pretty theoretical, doesn't it? I know, but don't worry. You'll see an example in a minute and it will become very clear after that. But for now, just know that an interface can be public or non-public. So what is the difference between the two? Well, a public interface is meant to be accessed by anyone. The objects in that interface are not prefixed with underscores. So examples could be account or balance. Whereas the non-public interface, that is meant to be accessed by internal implementation only. And we will see an example of what that means. Actually, in the next lesson, we will see plenty of examples of what that means. But importantly, these are prefixed with underscores. So they start with 1 or more underscores. For example, underscore account or underscore underscore balance. Now note that the slides say meant to, because the naming convention doesn't actually stop you from accessing the non-public objects. That's why Python uses the term non-public as opposed to private. And we'll see some examples in later videos where I show you that you can actually access the non-public objects. But this is different from other programming languages, such as C++, for example, where there are actually specific keywords to define private objects. Now, how that works exactly is not for this course. Clearly, we are looking at Python and how it works in Python. And if you want to find out how things work in Python, what do? Look at the PEPs. So please go back to PEP 8, the style guide. And there you will find a section called Designing for Inheritance. Public attributes are those that you expect unrelated clients of your class to use with your commitment to avoid backwards incompatible changes. Non-public attributes are those that are not intended to be used by third parties. You make no guarantees that non-public attributes won't change or even be removed. So these guidelines are clearly written for designers, so it's written from the point of view of a designer. Now, you can be a designer, well, you are a designer when you are writing your own package or your own code, but you are also a user when you are using someone else's package or someone else's code. So from this, what are the key takeaways? Public objects are being used by others. That is the key point, really. So public objects should be descriptive so that they are clear to the user. They should be intuitive, again, so that they are clear and stable over time. This is the backwards compatibility that the PEP was referring to. Public objects, therefore, need to be properly documented because, well, they will be used by others, and then it's important that others know what this function or this object actually does. Therefore, also, objects that you are likely to change over time should remain non-public, such that no third party uses those objects, and therefore, when you change it, their code doesn't break. And then lastly, for you as a user, objects whose names start with an underscore or multiple underscores in someone else's code should be considered non-public and therefore should not be used. Now here is another example of why it is important to stick to the Python conventions. Because many Python tools, such as code editors or IDEs, code linters, and REPL apps, rely on the leading underscore naming convention to distinguish between public and non-public objects. Just to elaborate on that statement, let's have a look at how IDEs might rely or at least take account of the naming convention of having leading underscores. So the class myClass here has two methods, a public method, which does not start with an underscore. And all this method does is it prints the word public. And then there's a private method, which starts with an underscore. And all that does is it prints the word private. We then have our if underscore underscore name underscore underscore equals underscore underscore main section, where we create an instance of my class, and then we access the public method of my class, and then we access the private method of the class. Importantly, currently, the IDE is not showing any errors or is not giving us any messages. Just to show you that the code works, let's quickly run that. So what happens here is that the word public is printed because that's what we asked this statement to do here. And then the word private is printed as well because we accessed the private method of my class. So the code works. But what I really wanted to show you is that you can change a setting, and this is VS Code. It might be different for the IDE that you're using, but you can change a setting such that the private method is highlighted, or it gives you a warning that this is a private method. So how do we do that in VS Code? You press Control, Shift, and P, and then you open the preferences, so open user settings, and we open the JSON file. And at the very end of that file, within the dictionary, add setting. We have to adjust the setting. And for convenience, I'm just going to copy paste that in because it's a bit long to type. Just have to make sure that it lines up. So what this is doing, this is another setting. So it's the diagnostic severity overrides, and the report private usage is an error. So in other words, if there's private usage suggested by the underscore or leading underscore, then we will get an error. So let's save that and close the window. You might have noticed that as soon as I closed the settings window, there was a red squiggly line that appeared under the line of code where we access the private method. And if you hover over that, it will give you an error message or a warning saying that private method is protected and used outside of the class in which it is declared. So this is an example of how IDEs rely on the use of the single leading underscore to distinguish between public and non-public attributes or objects. In the next lesson, I'll guide you through a real-world example to bring this theory to life. See you there. In this video, you'll be looking at a real-life example. You'll be looking at the dir function. We'll be using that function to investigate the string class or the str class from the built-in functions in the Python standard library. So please move to your REPL. So in your terminal, you start your REPL as we have done before using Python or Python 3. You see the three arrows in front of your cursor, so you are in the REPL. And you type in dir and then str. Press enter. And now you can see all the objects that are available in the string class, the str class. So you have underscore underscore add, underscore underscore class, underscore underscore. Lots of those that have underscore underscore. One of those is underscore underscore init. But then there's also quite a few that don't start with an underscore. Capitalize, casefold, center, count, and so on. So what have you learned from the dir example or the str example? There were some public methods there. Is numeric, replace, split, so they don't start with an underscore. There were special methods there to underscore underscore add underscore underscore. That's quite a tongue twister. So that's double underscore add double underscore, or a dunder method. And we will talk about those in more detail later in the course, but there were a few of those with 2 leading and 2 trailing underscores. Were there any non-public ones starting with a single underscore? I didn't see one, but let's have a look at the output. I don't see any that start with an underscore. I see format underscore map, which clearly has an underscore, but it doesn't start with one. So none of the non-public methods starting with a single underscore. And I also didn't see any starting with a double underscore that did not end with 2 underscores. So no non-public methods starting with a double underscore. So now that you know the difference between a public and a non-public interface, you are ready to tackle single leading underscores. See you in the next lesson. Single leading underscores for non-public objects in Python. First, let's have a look at where we are exactly in the course. Looking back at our summary of relevant naming conventions, we are at the first row of this table, so single leading underscores. And names with single leading underscores indicate that the name is meant for internal use. It looks like we are using 2 terms here, internal and non-public. How are they related? Well, they are really just 2 sides of the same coin. An object is internal within the containing class, the module, or the package. So that means within the module, for example, that it was written, it is internal within that module. But that means it's non-public outside of that module. So it will be non-public outside of the containing class, the module, or the package. Now, I think we're going to need a few examples here to show you exactly what that means. So here's a table that is roughly representing the structure of a package. So on the left-hand side, you have the package that is the highest level. The way to read this table is a package can have several modules, and a module can have several objects like constants, variables, functions, and classes. And classes can have members such as attributes and methods. And in the name column, we have a number of examples. And then in the example column, there are the examples that we will be looking at. So you will be looking at 5 examples, and you can always come back to this table to get your bearings and to see how these examples are related. For our first example, we will be looking at a constant underscore pi and a function underscore validate. Right, enough tables and theory for now. In the next video, you'll get your hands dirty with your example number 1. In this lesson, you'll study the use of an internal constant. We are looking at underscore pi in example number 1. You're going to create a class called circle, and that circle class will take 1 parameter, its radius, and it will also have 1 method to calculate the circle's area. Now, you might remember that to calculate a circle's area, you need a constant called pi, and it is this constant that we will make an internal constant underscore pi. So that's your objective. If you please switch to your favorite code editor and create a file called shapes.py. And then I'm going to hide this to give us a bit more space. And then we create our constant underscore pi. It is underscore pi because it is an internal constant. Then create a class called circle with a capital. That is a naming convention for Python for classes. And then create the init method. Self is what we usually use. And then radius. And then assign a radius to self.radius. So we have our class's attribute. Now we create a class's method called calculate area. And what we will return is, well, the calculated area. So you return the area. The formula for that is, in our case, underscore pi, our internal constant, times radius to the power of 2. But because we are in our class here, we will be using the attribute, so self.radius to the power of 2. And I'm going to round this to 2 decimals, just to keep it clean. So round to 2 decimals, and that is our class. So the thing to note here is that underscore pi is an internal constant. It is internal to the shapes.py module. It is therefore non-public outside of the shapes.py module. So it's internal to shapes.py, so you can use it freely within this module, but it shouldn't be used or it shouldn't be accessed outside of the shapes.py module. The final note I would like to add here is that, of course, the point of this example is to show you the use of an internal constant underscore pi. In the real world, if you need to use pi, that is actually available in the math library. So you would probably import it from there. So from math, import pi. If then instead of underscore pi, you use pi, you will have a more accurate outcome. In the next video, you will be expanding on this example by building an internal function. See you there.